The big challenge will be to try and mitigate the effects of climate change by changing the way we create and use energy, transport and food production. But could there be other ways of using technology we already have today to try and reduce the size and the energy of some of the more localized destructive weather events like tornadoes and hurricanes, and control rainfall? Controlling the weather, or weather modification as it's known, has long been the goal of many. From those wanting to make things better for their fellow man, to those looking to make it somewhat worse by weaponizing the weather. And it's not as if we haven't been trying. One of the most well-known methods of weather modification is cloud seeding. This is basically spraying tiny particles of silver iodide, dry ice or frozen carbon dioxide, liquid propane and more recently table salt into clouds by planes, rockets and flares. Although this method has been done for over 70 years, there's still a lot of debate as to how effective it really is. But in what was called the most scientific study of cloud seeding carried out so far in Wyoming, over a 6-year period, seeding mountain clouds, it was concluded that it produced about a 10% increase in precipitation. But equally, that different areas and conditions around the world could produce more or maybe have no effect whatsoever. There are two basic methods, the cold rain method and the warm rain method. The cold rain method works in more temperate areas where large convective clouds contain supercooled water. The seeding agents like dry ice provide a nuclei for the supercooled water to freeze around, which then travel on the updrafts into the cloud, picking up more water as they grow larger. When they are large enough, they then fall and melt into rain on the way down. If the storm is very large and has very strong updrafts, they can become so large they don't melt on the way down, but fall as hail. The warm rain method is used in tropical areas where the clouds don't reach the freezing point. So a hygroscopic seed, that's one which absorbs water like salt, is used instead. The tiny droplets coalesce as they also float up and down on the downdrafts, again until they are heavy enough to fall as rain. However, if you use too much seed material, then it can have the opposite effect by creating too many seeds for the amount of water vapor available. so very few of them can grow large enough to become raindrops. And here we have another underlying issue. Natural rain requires a seed to start the process, which would normally be a particle of dust or pollen. But our use of fossil fuels, especially diesel and coal, also creates a lot of soot, which can also act as a seed. So just driving your car or putting your heating on, you could be unintentionally seeding the clouds. This pollution has been blamed for the lack of the snowpack in recent decades in areas like the western US that rely upon clouds forming over mountains and the snow they deposit for the meltwater for their water supplies. If the clouds are seeded by pollution before they reach the mountains, there will be less snowfall and less water. So seeding the clouds over the mountains is seen as a way of bringing back the snow and increasing the water supply. Another experiment using ionized particles is being trialled in the Middle East in Abu Dhabi. The idea here is that the negatively charged particles are released from ion emitters and float upwards on the convection currents and attach themselves to the natural condensation nuclei in the clouds. Once charged, they would attract other nuclei and grow more quickly and hopefully survive longer to produce more rain than it would have done without being charged. So far, they say the results have been positive, but more research is required. A common misconception is that cloud seeding can create rain or snow at will and anywhere, and from clear skies. This is false. It can only affect clouds which are already existing and are rain or snow bearing or at just the point of becoming so. If there are no clouds, or there are clouds which cannot produce rain, such as the very high cirrus clouds, then no amount of seeding will make any difference. It's also been found that clouds that form over the sea are more likely to respond to seeding than those that form inland. Hail suppression is another reason why seeding of large thunderstorms is done in parts of the world where hailstones routinely grow to very large sizes and cause damage to crops, vehicles, buildings, and people. Although the exact details of how hailstones in these storms grow are still sketchy, the idea is that seeding them will cause more of the supercooled water to fall as rain earlier and reduce the amount that is available for hailstones to form and thus reduce their size. In fact, it's been found that the tips of propellers of aircraft and also the airflow over their wings can produce ice particles from the cloud's water vapor under certain conditions, and unintentionally seed clouds which could be wrongly attributed to seeding itself. But this hasn't stopped many countries around the world from trying it. China has invested heavily in cloud seeding and even used it to try and keep the opening and closing ceremonies of the 2008 Beijing Olympics rain and smog free. Whilst China says that they have had great success, it also has some of the most polluted skies in the world, further confusing the results. It's been reported that they have deployed over 500 solid fuel burners on the high slopes of the Tibetan Plateau to pump out silver iodide in an experiment to try and increase the amount of snow and rain across a 1.6 million square kilometre area that eventually feeds into the Yellow, Yangtze and Mekong rivers. Even though in the West silver iodide is increasingly seen as a pollutant and therefore not used as much. But as they say, one man's pitchfork is another man's weapon of war, and so it was with cloud seeding in the Vietnam War when the US carried out the secret CIA-sponsored Operation Popeye from 1967 to 72 under the auspices of weather reconnaissance. This was an attempt to try and increase the length of the monsoon season with cloud seeding, with the intention of causing damage due to extra rainfall to roads, river crossings, inducing landslides, and generally making life more difficult with year-round mud for the Viet Cong along the Ho Chi Minh Trail, the main route for transporting men and arms to the south, but which also covered parts of Cambodia, Laos as well as Vietnam. Only after the programme's existence was leaked in 1971 did operations cease in 1972, after details of it were published in the New York Times. This highlights the issue that the effects of increased rainfall don't stay in the area where the seeding took place or the rain fell. Flash floods along river courses could happen far from the rainfall and even in other countries. So if we could affect the rainfall, then we should be able to affect storms and the biggest of all, tropical cyclones or hurricanes. Project Cirrus was a collaboration between the US Army Corps and General Electric to drop crushed dry ice or frozen carbon dioxide from a modified bomber into rain bands of a hurricane in 1947. And this is actually the basis of all modern cloud seeding. The theory was that the dry ice would cause a new eye wall to form, which would be larger than the old one. This would reduce the pressure gradient and weaken the hurricane. After receding, the storm did a quick turn and made landfall near Savannah, Georgia. People blamed the change of direction on the seeding, and legal action for damage caused was threatened, which stopped further trials for over 10 years. Later it was discovered that a similar storm had done the same thing in 1906, and that the 1947 storm was probably already starting to turn before the seeding started, and this stopped the legal action. Project Storm Fury was a further attempt to weaken hurricanes by the US government from 1962 to 63. Again, this used cloud seeding, but this time with silver iodide, which mimics the effect of dry ice whilst being easier to handle and longer lasting. This was supposed to try and make the supercooled water in the hurricanes freeze and disrupt its inner structure. However, it was found that most hurricanes don't have enough supercooled water, and that the unseeded hurricanes changed in the same way as a seeded one was expected to, pretty much making the project redundant. By the late 1950s, nuking hurricanes into submission was seriously considered. The idea was that if you exploded a high-yield weapon above the eye, the huge uplift of air seen in the fireball would suck in cool air below and disrupt the storm's convection currents. But there are some serious drawbacks to this. The most obvious being that it would have spread highly radioactive isotopes through the wind and rain and over a wide area. The second issue is that hurricanes are heat engines. They get their energy from the warm, moist air above the ocean, so adding more heat from the blast will probably make it stronger rather than weaker. And the third problem is the sheer amount of energy already being released by a hurricane, which in a typical one is equivalent to a 10 megaton weapon being detonated every 20 minutes. So a succession of high-yield bombs will be needed to have the required effect. As hurricanes are just air and water vapor, the blast shockwave would have little effect on its structure, and what water vapor might be superheated from the initial X-ray burst would soon condense back again in a short time after, adding more heat in the process. So, if you can't stop them when they're large, maybe you could stall them when they are developing, and just storms at sea. For a hurricane to develop, the sea temperature must be above 26.5 degrees Celsius. Around 80 tropical depressions form in an average year in the Atlantic Basin, but only around 5 to 10 or so become hurricanes. So which ones do you go for? Instead of trying to figure out which ones might become a hurricane, why not affect them all? There have been several ideas to cool the ocean's surface in the area where they develop using wave-powered pumps, also known as ocean ploughing, to either move warm surface water downwards or cool deep water upwards. The issue here is that you would need thousands of these covering a vast area, and in small-scale tests many of these pumps were damaged by the waves. Another idea which is already being used in Norway to stop the buildup of ice in fjords is to pump air into the deep water. As the air bubbles rise to the surface, they bring up the deeper salty water which stops the ice from forming. If this was done in the warm ocean waters, it could bring up the deeper, cooler water to cool the surface and deprive the storms of the heat energy to grow into hurricanes. Again, the same issue applies in that you would need thousands of these solar-powered pumping plants covering a large area to have any effect. And yet another idea is to make the clouds themselves more reflective by spraying seawater into them. This would reflect more of the sun's energy back into space and cooling the sea below. This has been suggested to help combat global warming, and if this was done around the equator, then not only would it reduce the amount of available energy for storms to form, but it would also help cool the poles, as the whole point of the atmospheric and ocean currents is to distribute the heat imbalance from the equator to the poles. However, there is also the law of unintended consequences on sea life and any new weather patterns that may become established if we were to artificially cool large areas of the oceans. Tornadoes are the other deadly storms, but these are quite different from hurricanes. For one, they are much smaller, with an average width of just 0.8 kilometers, and give very little notice of when they form. The funnel clouds lasting from a few minutes to a couple of hours, but in that time they can do tremendous amounts of damage to anything they encounter. Unlike hurricanes, tornadoes nearly always form over land from large rotating thunderstorms or supercells. These require cold, dry air over warm, humid air and an unstable atmosphere, something which happens regularly over the Great Plains of the central US in an area called Tornado Alley. Because they form in a different way to hurricanes, primarily due to the difference between the cool, dry air and the warm, moist air masses, and the lateral winds which provide the spin to get them going, there have been several theories as to how they could be controlled. One was from the physicist Bernard Eastland, who, if you've seen our video on HAARP, was the man behind the idea of the giant ionospheric heater in Alaska that was supposed to be able to heat the ionosphere to create a lens to focus the sun's energy onto an area maybe hundreds of kilometers away. Well, the thunderstorm solar power satellite, which he called it, would be a giant solar collector that would generate electricity and convert it into microwaves, which would then be focused onto thunderstorms to heat the cool, rainy downdrafts, disrupting the convection currents within the storm cell. This might sound far-fetched, but if you've watched our previous video about space-based electrical power generation, then you'll know that they're already trialling microwave power link technology and the satellite-based solar power generators, so it might not be that far-fetched for long. But there are problems with this idea too. Firstly, the solar power station and microwave transmitter would need to be in geostationary orbit to stay above the area and to have a 24-hour supply of sunlight for its power. But that would place them over the equator rather than the central US. At 36,000 kilometers away, the beam would also be very wide, at up to 10 kilometers across, and not focused enough to pick out the small area of the cool air in the rear flank downdraft of thunderstorms where most tornadoes start. If you heat up the surrounding air more with already warm air, it might just make any existing tornadoes even stronger. If a satellite was in low Earth orbit at 400 kilometers, then the beam could be a lot tighter and stronger, but it will be traveling around the Earth once every 90 minutes or so, with only a few minutes over a potential target. Getting the satellite to be over a storm at the right time and in daylight for its power would be down to luck rather than planning. You would also have to avoid the high energy beam from hitting people and livestock on the ground, so it would have to be turned off when over towns and villages. A variation on this is a ground-based system with high-power microwave transmitters mounted on trucks with large generators. This gets around the problem of being close enough, but you would still need many megawatts, so a convoy of transmitters and generators would have to track down the storms like storm chasers do now. They would then need to stop and set up with just a few minutes to be effective, all whilst trying to avoid any emerging tornadoes. In the real world, this would just not be practical with current power technology and transportation. So our best hope is for better detection and prediction of where the tornadoes may form, and maybe more underground buildings and structures that would not be affected. Accurate weather prediction has come a long way in the last 20 years or so, using a whole variety of methods, from real-time updating of data in the field to predictive modelling on supercomputers. But all of this requires skills in ways of thinking like a scientist. Brilliant! The sponsors for this video is a problem-solving website that can help you develop these skills by breaking down problems into small, easily understandable parts, then putting them back together to show you the overall solution. You can download any of their dozens of interactive courses through the mobile app, and you'll be able to solve fascinating problems in math, science and computer science no matter where you are or how spotty your internet connection may be. What's great about these courses is that they're all totally interactive. You'll experiment with pendulum clocks to master the physics of motion, use rockets to model algebraic functions, and learn probability by playing casino blackjack. I particularly like the course about quantum computing. So if you want to support Curious Droid and get unlimited access to all of Brilliant's in-depth math and science courses, you can head on over to brilliant.org/Curious Droid to get 20% off of their annual premium subscription.